A researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 25 adult Americans and asks whether or not they support the proposed changes. To say that the distribution of the sample proportion of adults who respond yes is approximately normal, how many more adult Americans does the researcher need to sample in the following cases? 10% of adult Americans support the changes. The researcher must ask blank more American adults round up to the nearest integer. So, key things here is that we've already obtained a sample of 25 and we want to know how many more do we need to sample. Right? So, sampling pretty small amount here, so we're talking about Americans, so chances are that our sample size is less than or equal to 5% of the population. So we're concerned about the condition n times p times 1 minus p being greater than or equal to 10 for the distribution to be approximately normal. So this is what we're trying to satisfy. So for simplicity, we're just going to look at the case where it's equal. And then we round up to the nearest integer to make sure that that's actually in fact true. So we already have 25, so we're going to do n plus 25 because that's our entire sample size in this case, and then p is going to be our 10%, and then 1 minus p is 0.1. 1 minus p is 1 minus 0.1, and then we're going to set that equal to 10, and then we're just solving this equation for n. So let's do 0.10 times 1 minus 0.10, so 0.10 parenthesis 1 minus 0.10 close parenthesis enter. So we have n plus 25 times 0.09 equals 10. So now I can divide both sides by this 0.09. Doing that, this will cancel, so I'm left with n plus 25, and then if I do 10 divided by 0.09, we get 111.1 repeating, so I'm just going to write that down. So that borrowing number just means that it repeats. And then I'm going to subtract, so n, 25 is added to n, so the reverse operation is subtraction. So I'm going to subtract 25 from both sides. When I do that, we get 86.1 repeating there. So if we round up, so typically if we round this would be 86, but we round up, so this is 87. So we need to ask 87 more adults. So let's look at why we couldn't use 86 for a second. So over here, why 86 doesn't work. So 86 plus 25, right, because we've already sampled 25, gives us 111 people, right? So if we do 111 as our sample size times our p, which is 0.1, times 1 minus p, right? So 111, parenthesis, 0.1, close parenthesis, open parenthesis, 1 minus 0.1, close parenthesis, enter. We get 9.99, and that is not greater than or equal to 10, right? No, right? So that's why we round up. So let's look at the next case. So we want 15% in this case, right? We still have the 25, and we want to know how many more, right? So we have n plus 25. Let's write our condition out. N, p, 1 minus p needs to be greater than or equal to 10. And then our p in this case is 0.15, and 1 minus 0.15. and let's set that equal to 10. So 0.15 parenthesis 1 minus 0.15. We multiply these in the calculator, we get 0.1275. Now we have n plus 25 as a quantity times 0.1275 equals 10. So now I'm going to divide both sides by 0.1275. And I'm left with n plus 25 equals 10 divided by 0.1275. When I do that division, I get 78.43137.255. So I'm just writing down that whole decimal for now. And if I subtract 25 from that, right, we get 53.43137255. And we always round up, so this is going to give us 54. So we need to ask 54 more Americans, adult Americans in this case.